Choosing the right volume potentiometer for your audio build can be a complex journey, often filled with conflicting opinions. In high-fidelity audio design, attenuation is far more than just adjusting loudness. It is an electromechanical stage that directly interacts with your analog signal path. Selecting the ideal architecture requires careful matching, as different topologies inherently influence transient response, channel tracking balance, and overall soundstage transparency before reaching your amplification stage. Welcome to our comprehensive volume masterclass. Today, we are analyzing the underlying engineering principles of the 5 major architectures, exploring our real-world scoring matrix, and sharing a practical upgrade blueprint based on solid technical data. Let's evaluate the absolute best path for your unique system. Disclaimer: before we unpack the blueprint, a strict safety notice. DIY audio modifications involve high voltages and active power supplies that carry serious risks of electrical shock or hardware damage. The circuit engineering logic shared in this masterclass is for educational purposes only. You proceed entirely at your own risk. RTY DIY Audio assumes zero liability for any component failure or technical errors on your workbench. Always prioritize electrical safety and verify your circuit layout before you solder.
Agenda. Here is our Volume Masterclass course outline. We are structured into 10 strict technical chapters designed to systematically unpack total signal control. Chapter 1 to Chapter 3. We begin by identifying the core variables of sound degradation, mapping out modern topologies, and executing a direct side-by-side comparative matrix. Chapter 4 to Chapter 5. From there, we explore our strategic selection guide, verify critical fitment limits, and dive straight into our hardware-specific recommendations. Chapter 6 to Chapter 10. Every milestone is engineered to deliver an actionable, lab-grade blueprint for your workbench.
Let's start at Chapter 1. Why does sound change after a volume upgrade? In high-fidelity circuit design, the sole duty of an ideal potentiometer is to precisely attenuate the amplitude of your analog signal. Therefore, a mathematically perfect attenuator must scale down the signal's amplitude while remaining completely transparent, meaning it must induce absolute zero frequency coloration, zero phase shift, and enforce a flawless 100% channel balance across all listening levels. However, the harsh electromechanical reality is that every physical volume control introduces 4 devastating degradation factors that inherently color your sound. Let's expose these variables and understand why a strategic hardware upgrade is mandatory for your workbench. First, channel tracking error, which shifts your stereo imaging off balance. Second, intrinsic material noise, which raises the noise floor and masks micro details. Third, sweep linearity, causing erratic volume jumps. And fourth, structural sonic character, where materials like carbon or plastic inject unique tonal flavors. Shifting your potentiometer changes the baseline clarity of your entire machine.
Chapter 2. Audio Volume Topology Classification. Number 1. To achieve absolute control over your audio signal, you must understand the 5 primary architectures used in home audio systems. Looking at this matrix, you can see their physical footprints and real-world shapes. Each design operates on a completely distinct electrical and mechanical framework, long before any brand name is even considered. From traditional analog carbon tracks, mirror-smooth resins, and physical stepping switches to active semiconductor silicon chips and micro-relay arrays. But why do we have so many complex options? Let's reveal the architectural truth behind their evolution. Moving into classification number 2, the evolution and resolution of audio volume. Every single architecture was engineered specifically to crush the fatal limitations of its predecessor. The 1930s carbon comp offered a smooth analog baseline, but suffered from brutal low-volume tracking errors. To solve this trackware, the 1970s conductive plastic replaced carbon with polished resin, yet channel imbalance remained.
To achieve absolute channel balance, the 1980s step attenuator introduced fixed discrete resistor networks, completely eliminating tracking errors. Crucially, this setup opens the path for fully customizable boutique resistor rolling, though it limits you to discrete, choppy steps. To regain micro-step smoothness and reduce bulk,
The 1990s digital volume IC migrated to silicon, but introduced semiconductor noise and severe bit stripping at low volumes. Finally, this evolutionary loop drives us to the ultimate summit, the R2R Ladder Network. By managing pure analog discrete relay pathways via digital microprocessor logic, it delivers absolute zero tracking error, zero bit stripping, and full support for legendary boutique resistor rolling, the definitive peak of volume engineering. Now that we have uncovered the critical electrical degradation factors from Chapter 1 and analyzed the 5 core topologies from Chapter 2, let's lock them together. Look at this comprehensive comparative matrix. We are laying down every single framework side by side against our 4 electrical variables to expose their true raw behavior. Watch how Carbon Comp trades terrible low-volume tracking errors for that legendary warm analog mid-range. See how Conductive Plastic smooths out friction noise while maintaining a transparent path.
Look closely at the step attenuator. It completely crushes tracking errors, but chains you to 24 to 48 discrete mechanical clicks. Notice how the digital IC runs dead silent on bitwise math, but suffers from resolution bit stripping at low volumes. And finally, the R2R Ladder Network stands at the absolute sonic summit, unifying perfect channel matching with uncompressed musical transparency. Study this blueprint carefully, because this data directly dictates how we execute our upcoming precision matching series.
Let's open Chapter 4 with our Strategic Selection Guide number 1. It is vital to realize that each volume architecture possesses unique electromechanical strengths and a distinct sound character. Because of these individual traits, your component upgrade pathway splits into 2 strategic choices. On the left is the safest option. Upgrading to a higher grade model within the exact same family enhances specifications and performance, while strictly preserving your system's original sonic identity. Conversely, on the right is the challenge option. Transitioning to a completely different topology allows you to dynamically alter the system's character, but introduces a subjective risk of wasted investment if the resulting flavor doesn't match your ears. Let's cross-analyze their exact variables in the next phase. Let's advance to Chapter 4, the Strategic Selection Guide. To execute a flawless component upgrade, we must cross-analyze our choices inside a strict lab-grade scoring matrix from 1 to 10, balancing signal transparency against acoustic warmth.
Look at the data carefully. Carbon Comp natively drops to a 3 on transparency due to heavy material damping, but remains the absolute champion with a perfect 10 on organic warmth, while its channel balance natively flatlines at a 2, utilizing a dual mono volume layout instantly enforces a perfect 10 balance. The R2R Ladder Network stands at the absolute engineering summit, scoring a definitive 10 across transparency, balance, resolution, and noise floor, while sitting at a native 6 on warmth, which easily skyrockets to a 9 when rolling in boutique carbon resistors. Step attenuators deliver an ultra-sharp score of 9 on transparency, backed by laser-accurate precision resistors, but are mechanically restricted to 24 to 48 choppy steps. Conductive Plastic offers a highly linear, uncolored transparency score of 8 with a fluid tracking sweep. Meanwhile, digital volume ICs provide computational bitwise tracking accuracy, but introduce a drier, analytical silicon noise floor. Study this matrix. Always match your hardware upgrade based on your true listening priorities and real-world environment. Let's look at Chapter 5, Critical Workbench Warnings and Fitment Limits. Before you solder, you must commit to 4 absolute hardware rules. First, exact resistance match. Never guess the specs. Swapping a stock 10K pot with a 100K pot completely shifts circuit loading and cuts back high-frequency air. Second, taper configuration. Always verify that you are using an audio or logarithmic taper to ensure smooth, natural volume scaling. Third, physical footprint clearance. Discrete step attenuators and R2R networks are massive. Measure your vertical depth to eliminate grounding short circuits against the chassis wall. And fourth, mechanical shaft optimization. Check your shaft diameter, 6mm versus 1/4 inch,
to guarantee your factory front knob remounts perfectly. Measure thrice, solder once.
Moving into Chapter 6, our prescriptive recommendations for the Carbon Comp series. If you desire organic analog smoothness, this is your map. At the entry tier, the ALPS RK27 Blue Velvet stands as the industry standard benchmark, incredibly reducing channel tracking errors compared to budget pots while providing robust bass weight. For the intermediate stage, the Japanese TOCOS RV24 delivers military-grade composite precision, offering a noticeably sharper stereo image and a lower background noise floor. And at the high-end summit, the legendary Allen Bradley Vintage NOS reigns as the ultimate holy grail. It is meticulously engineered with a hot-molded solid carbon element that injects maximum organic harmonic body, buttery smooth vocals, and a warm, tube-like rich mid-range response. Match it right, flush it clean. Let's advance to Chapter 7, our prescriptive recommendations for the Conductive Plastic series. If you crave uncolored reference purity, look right here. At the entry tier, the ALPS RK501 high-end carbon hybrid breaks the mold, combining the absolute best of organic carbon hybrid fluidity with upgraded high-precision conductive tracking. For the intermediate stage, the Japanese TKD Tokyo Koon Denpa 2CP2500 delivers pure laboratory reference-grade transparency, opening up immense acoustic air. And at the high-end summit, the legendary Penny & Giles Studio Pot stands as the definitive international broadcast master standard, offering extreme mechanical luxury and an absolute dead silent sweep across your entire audio path. Solder it once, enjoy perfection forever. Let's dive into Chapter 8, the Step Attenuator series. If you demand absolute channel balance, this is your precision playground. At the entry level, the Dale Resistor Chinese 24-step gives you a reliable taste of discrete stepping, though the mechanical rotation feels slightly stiff. Moving to intermediate, the EIZZ 24-step Carbon R option steps up, loaded with premium Amtrans Japan carbon film resistors to successfully deliver a warmer, organic musical body while enforcing zero tracking errors. At the advanced stage, the Khozmo acoustic attenuator delivers a massive sweep inside a boutique copper shield chassis with fully customizable resistor layout options. And at the high-end summit, the Swiss-made DACT CT2 offers a blisteringly fast transient layout with immaculate high-frequency resolution. Let's advance to Chapter 9, Digital Volume Control Recommendations. To ensure complete clarity for your build, we are splitting this matrix by component type. At the entry tier, the PGA 2311 by Texas Instruments offers clean active gain scaling. You can source the bare chip alone for around $10, or opt for a completed board kit with a remote for roughly $30. Moving to intermediate, the legendary MUSES 72323 stands as the definitive summit of silicon attenuation technology. The naked chip runs around $20, while a fully assembled, high-end completed board with an OLED display sits near $85. Evaluate your mechanical chassis space and select your pathway accordingly.
Finally, we reach Chapter 10, the R2R Ladder Network recommendations, the absolute sonic summit. At the entry stage, the Yisheng Audio 256-step R2R kit costs near $45, utilizing a vertical stacked layout that inherently forces an ultra-short signal path, fully armed with military-grade Beijing 718 resistors. Moving to intermediate, the Zidang Audio Premium R2R kit at $90 builds upon that same ultra-short path with premium Dale resistors, integrating a digital display and remote control for modern workbench flexibility. For the advanced builder, the AMB Delta 1 Bespoke DIY kit sits at $150, offering a laboratory-grade circuit canvas that opens the gate for custom boutique resistor rolling. And at the ultimate high-end peak, the custom Khozmo 64-step ladder type starts at $600, packed with internal micro relays and boutique naked foil options to deliver the ultimate uncompressed audio blueprint. Build it right, match it perfectly.
In conclusion, our upgrade blueprint highlights a fundamental rule in high-end audio.
Specifications on paper achieve true value only when matched properly to your real-world listening environment. Matching your upgrade to your system's current speed and material synergy is always more effective than blindly chasing the highest price tag. If this technical analysis brought clarity to your current Workbench project, please consider subscribing and liking RTI DIY Audio. Feel free to share your own build experiences or questions in the comments section. Turn up your soldering irons and let's continue chasing our passion for precision sound. Thank you for watching and see you on the next build.